Hello everyone, welcome back to another AP Physics 1 review problem. Today we'll be going over question 8 and 9 in the MIT AP Physics 1 workbook. That'll be in the description for you guys to access. So without further ado, let's go ahead and go on with the question. A ball is thrown and follows the parabolic path shown above. Air friction is negligible. Point Q is the highest point on the path. Point P and R are the same height above the ground. So question 8 asks, how does the speeds of the ball at the 3 points compare? So one thing that would be very helpful to remember about parabolic motion is that when you have a parabolic like this, you can cut it in half. And once you cut it in half, the time it takes from here, so time 1 to the time it takes over here, time 2, they're the exact same time. So it takes the same amount of time to go up as it does to go down. And knowing that, that means that at the exact same point, right here and right here, these velocities are equal to each other since they're at the same height and they're at the same time. So that means the velocities are equal to each other. And since we know right here that says points P and R are at the same height, since we know that point P and R are at the same height, that means that here and here, the velocities must be equal. So if we look at our answer choices, we can see already that choice D says VP is equal to VR. So that's why it's leading me to choice D, since C, B, and A don't have that. But we have to check all parts of the question. So then the next part is asking about VQ. So VQ is at the top of the problem, because it says right here the highest point. And since we know it's the highest point, if you guys remember from the last video, at the top of a parabola, always at the top of the parabola, the velocity is equal to 0 meters per second, but the acceleration is equal to 9.8 meters per second squared. But in this case, we're asked only about the velocity. And since we know that the velocity is equal to 0 at the tallest point, we can say that VQ is equal to 0. And since we know VQ is equal to 0 and these two are the same, that still leads us to choice D as being our correct answer. Next up, question 9 asks, which of the following diagrams best shows the direction of the acceleration of the ball at point P? So right here, what is the acceleration? And as I just said, in a parabola, the acceleration is constant no matter where you are, right? And here is the object, here's the object, here's the object, here's the object. The velocity, the vertical velocity may decrease, 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 and then increase as it comes down. But the gravity is always pulling anything to the center of the earth. And since this is the ground right here, it's going to be pulling downwards no matter where it is in the path, because that's what gravity does. It pulls us to the center of the earth. And if we look at the answer choices, A is saying that the gravity is going to be pushing this way. It's going to be pushing this way. Well, that's not true. Since we know gravity pulls us down, why would it pull us to the top right? That wouldn't make sense. Here, gravity, for choice B, it says that the gravity is going to be pulling us to the right. But we know that the velocity is constant in the horizontal axis because there's no forces acting on the horizontal axis. The reason the velocity in the vertical axis changes is because we have gravity acting on it throughout the time. So that makes sure that B is incorrect. Choice C says it brings it straight down to the right. But going off what we just said for B, if it pulls it down to the right, then that means it's going to have a horizontal and a vertical component. And if you have a horizontal and a vertical component, that means both the horizontal and the vertical velocities are going to be changing. But since we know that only the vertical velocity is changing, that means all of the acceleration must be acting in the vertical position. So that leads us to choice D, which is the correct answer because it enforces what we just said about having it always pulling it down, acting only in the y-axis in the vertical component. Hope you guys enjoyed the video. If you guys have any tips or anything you guys would like me to go over with, please put it down in the comments. Hope you guys have a good day and continue your prepping.